Hi, in this video, while creating Lucky Wheel, I want to cover more advanced things. First of all, I want to show you how we can use UDIMs in UEFN to lower required materials number. Secondly, I want to show you what texture array is and how to use it. Then, I will show you how we can spin our wheel entirely using only material and make it work in local space. And finally, I will combine all that to make fully working Lucky Wheel, and in the next video, I will write a verse code to control it directly from the verse device. As always, all my source files are available for visionary supporters on my Patreon, link in the description of the video. So let's begin. Okay, I want to start by showing my 3D model. Again, doesn't matter how it looks, most important is screen because it's divided into slots. So your style could be totally different. And let's look into UVs. So one most important thing, so like usually we're working between 0 and 1 UV space. And this is this one quad. And normally game engines, they're not working with outside space. So when something in your mesh UV is going outside of the space, it's actually wraps. So that's how we're applying tiled textures on the assets. But there is space outside, and we're calling them UDIMs. And if we click here, we can increase the styles. You see, so like that. And it's actually in Blender, it shows like this, like for example, X on only 10, but it can go like probably infinitely. It looks like that. And if now I will select my screen, you can see that my screen, these UVs, they're going way far from this 0 to 1 space. And it's actually how it works is I split it like that. So this will be my one slot, and this is where my this UV like seams will be. And I'm filling it entirely perfectly in 0 to 1 quad, because in your case you may have some this empty space in between, but most importantly that your UVs, this slot should be in the center, because here will be our image, weapon, item, wherever it will be there. But I'm using from side to side because then I have on my screen texture, which with some tiled pattern, and to make it tile really nicely, so I needed it to look like that. And then, so what I did, so I just created this, and then I just duplicated in a circle. So I created 16 slots. And if I'm selecting now next one, as you can see now in this one, it will be in this space. So it's UDIM second one. And then if I'm selecting this, so next one and next one, next one. And most important thing as well is if you're duplicating this for our technique, so make sure that your slots, it's exactly represents like first slot. So for example, if this one it's in this space, but it still holds this box, same as this slot. This is important because then when we will change slots, then you will have some offset if they not match. And I think that's it. So this is one of the most important things. So it looks like that, and when you will export, it will work automatically. Okay, so I have 2 static meshes. It could be even 1, because we can apply materials even if it would be like 1 solid mesh. But I combined all these pieces as a body and then separate for the screen. For the body, I created super simple PBR material, as you can see here. So it contains normal map, then color map, and then RM, so it's ambient occlusion, roughness, and metallic. And I created 2 instances because it's a really big mesh. So I applied 2 materials on this, and then third will be our screen. And so then I have all these images, 16 images for each slot. And then I have textures for, so this 6 textures for the body. And then these 2 textures will be for screen slot. So that's what I said, like there will be pattern, tiled pattern. So this is simple mask, black and white. So I set it to mask, and it's the same pattern, but this is normal map, and I reduced it to 512. Okay, so let's first create prop because we will need it later. So let's create blueprint class, prop, like you will. Let's open it. So very important is that our screen should be in this component. Body we will add as a separate static mesh component, but later on in the verse, we can only apply material to this component. We can't choose second, third, whatever. So we can only apply to first ones. And because we need screen, so then we need it there. So let's drag our screen to this static mesh. Let's compile. Then we have our material. Here we will add our feature material. Let's look inside. So for example, we don't need gravity, no event. So collision. If you will have collision, enable collision. And shadow, yes. Emissive light source can be because it will glow. This is mainly for lumen and this DirectX 12. This one, yes. In here, very important, evaluate world position offset. This must be ticked. If this won't tick, it basically won't spin because we want spin our mesh from the material. And this is actually done through the VPO, so world position offset. If this one won't tick, it basically won't work. Okay, that looks fine. Now let's add rest. So just drag it here. Then we have our body. You can choose no gravity, no event. That. In here it doesn't matter. So you see this now in this static mesh, it's enabled this world position offset, but we're not doing for body anything. So this can be enabled or disabled. Receive decals could be fine. Let's close that. Now if I will prop, this looks exactly the same. Can remove that. Okay, it looks good. Okay, this done. Now what we need is texture array. So what texture array is? It's pretty much Atlas, but for the Atlas we would need an additional program, for example Photoshop or GIMP, and we need then in that program we need to create Atlas, so where we're putting all these icons. Then later on maybe you decided to change this icon, so then again you need to go to that app, you need to bring your icon, you need to swap this. So it's efficient, but it's basically extra this work. Plus later on I want to do some manipulation, so again like rotation, scale of the icon. If we have that in Atlas, it's challenging, so then I need to lower size of each icon in the Atlas, creating some additional masks in material, so we're losing more pixels. But in here we can have all these icons separate. Let's go here, texture array. Let's call it TA, like texture array, maybe weapons. So if we will open that, it looks pretty much as a texture editor, but in here source textures. So we have 16, so I will add 16. So like that. So it means when I will have this texture array, next time if I want to swap maybe icon, I'm just like swapping that and it's done. I need to add them in specific order, in what order they will be on the screen of that wheel. Okay, and it's done. So why order is important? Because later on in the verse, I will be sending slot index, and this index should correspond to this. So it starts with a 0, 1, 2, 3, and so on. So then what's in the material we see, and what's in the verse, it basically will be same. Because same index we will send then into item granter. Okay, now in here, address X and Y, I will set to clump. What it means is basically if texture comes to edge of the 0 to 1 of this UV space, and then if something goes beyond, it's not repeats, it's basically clumps, it stops. In here we can set as well. Then in here we can use MIP maps actually, because for optimization it's really good. Then all of that, it's 248 by 248, it's pretty large, and as you can see, like it's pretty large size, like 87 megabytes. We don't need that for the icons. I think 512 is totally fine. So let's set that, and as you can see now, it's went from 80 megabytes to 5. It's really big difference. That's RGB. Okay, that's fine. Okay, so our array is done. So it's again, if you will need to swap icon, just make sure you know which index you need to swap, and that's it. So you're just bringing new icon and you're swapping. Additionally, from my another tutorial, I brought this here glint, so I will use on the final icon. Okay, let's start. So let's create material. will be like a wheel screen. Now let's create material instance and apply. So instead of drag and drop it here, I will do it inside of the blueprint. So let's select it here. There's material instance and apply it here. Okay, compile, save, close. So now it will be there. Okay, let's open our material. While I remember in here, let's enable all advanced. And sometimes I saw issue when I was using rotation with this WPO, like world position offset. In here, it says maximum world position offset, and it's unlimited when it's set to 0. And sometimes there is some weird behavior, so part of the mesh was disappearing during that. And what I found that with 1000, it was totally fine. So maybe leave it on a 0 and just check if it will work for you. Fine, then leave it. If something will be behaving weird, so try as well, like something 1000, maybe try another number. And I will say like always evaluate world position because we need it all the time anyways. So keep this in mind. Okay, let's first create rotation or spin for the screen. But first, to see it, let's add this pattern. So this will be our normal and mask. Let's maybe create color. For now, it doesn't matter what color. Fine, normal, save. Yes, like this pattern. Okay, so for the rotation, normally everything it rotates in the world space. So let's do state about axis, and then we need fix these normals, otherwise it will look really bad. So we need fixed normals. Then for this one, first of all, we need to tell on what coordinates, so basically x, y, or z to rotate. We can just use this. And then in here, so you can see that there is a green arrow, so it will be y. Then rotation angle, and later on we will control that parameter with reverse. But now I will just add time. It will go between 0 and 1 and again repeat and repeat just for testing. Then we need pivot, so it will be object pivot point, and for position, world position, like that, into world position offset. Okay, it's actually then should be X, I think. Okay, and you see this dark stuff, so this is our normals, issue with normals, but I won't care for now because it still won't work properly. So look now, it looks like it spins. What if my wheel is that way and look, it broke? Easy as that. Let's duplicate it because later we will need it for test. So we have it's that, and let's create another one, maybe even like this. So something challenging. So as you can see, it only works in one direction, and if I will set it that direction, so then I can just change to Y and it still will work. So it's basically perfectly aligned to world axis. And this is what we're calling local space. So this is object space, and we need that. Okay, how to do it? So let's keep this. And actually, I will create material function for that. It will be cleaner, advanced. It's called local rotation. And let's open that. Let's copy already this stuff here. And for now, we can open it on full screen. Okay, that I don't need. What I will do now, so I need object orientation, like this. Then I need transform, so not transform position, but transform vector, because everything, all these threads, they work in world space. So object orientation, world this space, so they will work in the world space. We need local space. So then in transform, we're changing from world space into local space. Then we need rotate vector and connect this one into this vector to rotate. Then I will create function input, and it will be, it's actually, yeah, vector 3 is fine. And it will go into look at vector. Here I will set use preview value, and this is if nothing will be inputted, it will use something from here. So I will set it maybe to y by default, and then I will use again transform vector. So we did this thing in local because we converted to local space, and now after that I'm changing it back from the local space into world space, and then I will normalize. So this I already sent to rotation axis, so this is to fix our normals, and then from here into normalized rotation axis. So I don't need that as well. So for rotation angle, I will need this input. Let's call it just rotation, and I need scalar. By default, it will be 0 everything. And what I want is basically that it resets to 0 after a certain amount of time, not time, but like value. And what this number is precisely, it's number of our slots. But in the future, number of slots may change. So in my case now it's 16, but I don't want to put just 16 because later on maybe it will be 20, maybe 12. So I will use another input for that. So this will be slots number. And maybe I will set just 1 by default. So what I want to do now is just divide. So this one will go into rotation angle into normal fix, and this one into this rotation. Now this one stays, and world position stays. And we've done here, just we need to output that. So let's duplicate. This will be new normal, and I'll set it normal output. Yeah, so normally see it's above world position offset, so that's why I will set it on the 0. And then this one will be our WPO, so then we know where to connect it. And then this one will be 1. So let's connect it here, and this one in here. When nothing is selected, we'll see these few parameters and expose to library ticked, because then we can find it in our search. Now if I will look local rotation, I have mf local rotation function. Actually, I need to organize inputs. So what I want first is this is our rotation axis. And actually, I forgot to name that. Rotation axis. Okay, so let's keep this one number 0. Then this one will be second, and this will be third. Okay, so now we can remove all that. We can keep all this, and we don't need that. So for rotation again, I will just, and actually I don't even need this anymore because inside it will change. So rotation, then slots numbers. So let's just use constant and 16, and this is our rotation axis. I think it should be Y. Now new normal, and then WPO. So WPO straight away can go into here, but normals, we have our texture, and then we have this, so we can't just directly connect them because otherwise we're losing texture. What we need is blend angle corrected normals. So this new normal, it should be as a base normal, and then this one as additional, and connect into normal like that. If we'll save and preview, check this out. Everything spins no matter of the position. Have it like that, it still spins as it should. Perfect. And plus there is no this black thing. And let's lower speed. We still have the details from the texture. Okay, that's working. Perfect. So we can keep this. We don't need time and this thing. Let's convert this to parameter, call it rotation local axis. Okay. Slots numbers, let's call it as well as a parameter. One important thing, if you want to access in a verse your parameter, you can't have space like this one between words. So this one, it won't be accessible, but I don't care about that. If I would care to access, so or delete space or just add underscore like that. And for the rotation. Okay, now let's work with a texture array. Before doing that, we need to do another material function for UDIMs. Because we have 16 of them, there would be quite large list, but don't worry, we just need it to do once, and then it will work automatically. What we will need, it's a switch, and for the switch, we will need how many? 16 inputs, and we would need to do this multiple times, because basically what I want is to control each icon scale and rotation when, for example, this icon is a winning icon, while rest icons should be static. Change background color, and then plus by using UDIMs just to tell from the array what index of the texture should be applied to what slot. So it pretty much like a 3 or at least 2 of these lists, but we can actually create function when we can do all this, and instead of like doing many times in here, we can do this in one function, just duplicate that function 16 times. So let's do that. Material, advanced material function. Let's call it just UDIMs. Let's open, throw it away, expose to library. Okay, first of all, input. So this will be scalar, and I will call it UDIM number. I will need it in another place. To make it clean, I will just create the root node name to root node, like that. Then I will subtract 1. I will explain in a second why I'm subtracting. Then append vector 0. Then we need texture coordinates and subtracting. Okay. As I said, I want scale, change background color for the winning icon only, but same time, I want that when nobody using wheel, that all icons should be static. There should be no change of the color, nothing, right? So that's why like I want that when I will pass number of a winning slot, I want that slot 0, it would mean that there is no winning icon, because otherwise we need some extra again math just to do that. So basically when I will pass 0, it means nothing. When I will pass 1, it will mean, okay, number 1 icon, it's winning. Number 2, number 3, and so on. But array starts with a 0. Okay, so what I will do, I will pass number 1, and then I'm subtracting this 1, and it will make 0. So if I will pass 2, and I'm subtracting 1, it will be 1. Yeah, so it's simple like that. Okay, so it's this. Then I need scale UVs by center, and again I want rotation, so I want custom rotator. So from these UVs I'm connecting to these UVs, and this will be actually output, so we can call it UVs. Okay, now I want time with speed. Let's set speed 0.5, then sign, and I want remapped sign. So from fracture time, I will connect into sign phase. Then in here, minimum and maximum, it will be 0.4 actually, and 0.75. Then I want lerp, and in here it will be this number, and in here it will be 0.75. Why 0.75? Basically when I will use weapons, they touching edge, just, but as you can see, I have some missing parts on my screen. So it means this weapon would go off and it would be cut out. So what I want to shrink it. So instead of using scale 1, which is full size, I want by default to have it already 75. And in here you see it's as well, it will shrink to 0.4 and then up to 0.75, not going to 1. And this is only for me. Again, it may be because of your scale and your UVs, or maybe even because of your icons, you will need different number. So try maybe 1. Okay. Now, what I want in here is basically to change when to use this and when to use just basically A. So I can connect this one to scale already. But then we need mask. And here I will use if statement. Let's grab this input and call it win slot, winning slot. And by default it will be 0. So I'm inputting this into A, and then as I said, I need this one, so UDIM number, okay, and 2 constant. So 0 will be if it's larger or smaller, and when it's equal, it will be not 10, it will be 1, like that. So basically, when through the verse we will pass in this winning slot, we will check what slot number is there, and because we will have 16 of them, so one of them will match. So if it will be 0, it means just use this and basically change nothing. But if it will be matching with something like 1, 2, 3 and something, then yes, change. Okay, now we have this winner slot and we can just add it in here. Now we can copy all that. Actually, I don't need lerp. Let's delete lerp. And instead of lerp, I will use multiply. So speed is same. Then rotation, it will be, because this will be rotation. So for the rotation, in my case, it's minus 0.1 and 0.1. Basically, we'll go like that a little bit. So it's not a full circle. Again, based on your UVs, based on your icons, may differ. So try it. And that's it. So this goes into rotation angle. You see, like that. Okay, and final thing, I want lerp, and I want 2 colors. So this is our background color. If you want in your background texture, use it here. Yeah, so instead of color, just add texture sample, convert to parameters, so later you can update. And for example, you can have like 2 textures, right? So maybe when winning slot is highlighted, so maybe you even swapping to different texture. Or you can multiply with a color, and then this background texture will have even color. In my case, I will just use color. So let's actually convert both of them to parameter. Okay, and I'm not using input because all slots should have same. There is no difference between slots. So even because later I will duplicate this material function 16 times, these colors, they should be same. So that's why, like in material instance, we will have just only 2 of them. So for this one, I will choose orange and this green. This one A, this one B. And from here, from this subtraction, I will multiply it with our winning slot. Then I will seal it. And just in case, saturate. Actually not so important after sealing because it's already clumping it, but I will still do it. And we need additional output. This will be our, and this will be second one, like that. So overall, what's happening in here? When we're passing number, this number gets subtracted. So let's say we're talking about 0. So then we are appending this one, and it will be 2. It's basically, we're appending, it will be x and y. So y it's always 0, and x it's horizontal. And it will be 0 or 1 or 2. Why we're doing this? It's actually because of the UDIMs. As I said, UDIMs can be as a number. It's basically offset. UEFN works with 0 to 1 space, and then because every next slot is in another UV space, it's basically offset by 1. Okay, so it means every time I want to rotate some slot, it would rotate with offset. So I want to fix this rotation and this by telling every time subtract slot number. So if, for example, slot number will be 10, so it will subtract, and like from here, so it will be 10, so it will be 9. And then from UVs, I'm subtracting that 9, and it will be, okay, this is how far this slot is in UDIM space, right? So eventually it will calculate based on 0 to 1 space anyways. So rotation and scale will be fixed, and it will know that what background should be changed in what slot. Okay, so like that, it looks fine. Let's save, go back to our material. So now let's drag our UDIM. Let's create parameter. This will be our win slot, no spaces, and I'll create a winner slot. Because I could use this one as duplicate, but as you can see, this node is quite big compared to this one. And because we need 16 of them, so space is really important. So what we need, win slot and UDIM number. Actually, I will set UDIM number above. So this one should be 1. Yep. So now this will be slot number 1, and then winner slot, just like that. And we need 16 of that. Okay, I think it's 16. Now we need just change number, so it's 2, 3. Okay, 16. Okay, so now in here, how we can tell that we need go into UDIM direction? It's pretty simple. So we're using texture coordinates, then we need mask component, and this is our UV space or X and Y. So if we will choose R, this will be our horizontal. And because in the beginning of the video, I showed that all my UDIMs are horizontally placed, so this is what I want. So I can take that, now connect this to switch value, and then I need to connect all of that. So first, this input and default should be exactly same thing, like that, and then rest. Now you see why we created material function, because like, imagine doing 16 times all this. Okay, so this is 1, and I need another 1, like that. Let's copy this switch value. And now into this one, we'll go color. Okay, it's done. A little bit messy, but we can't do anything about that. Nice spaghetti. Let's comment. And here we'll output reward node. Okay, so we have our UDIMs ready. Now we can use them to work with texture array. Let's save. You see this error, its material didn't allow automatic usage. What you need to do is scroll down where all this usage is and tick this box, so it automatically will detect. Now where's our array? So this is our array. So how texture array works? Normally, you see in our UVs we have vector 2. It's basically 2 coordinates, U, V, or X and Y. In texture array, it's actually 3. It's U, V, W. W represents index. So basically with that index, you're telling what texture to use to basically apply. In our case, each of the texture is icon for each separate slot. And that's where our UDIMs comes. So as I said, UDIMs, they have number. So UDIM 0, UDIM 1, 2, and this will be a representation of our slot. Okay, so let's create our texture coordinates, then you can see like even if I will connect it, and then let's connect this one to base color, it will error on us saying instead of float 2, it should be float 3, basically vector 3. So same thing, we need to use component mask, horizontal, and I will just use floor. So this will represent number. So I could do with a switch as well, that input this and then say into each of that input like 0, 1, 2, 3, 4. But it's actually possible just to do this and it will work exactly the same. So we need our UDIMs and we need append vector, and we are appending this. We'll connect. See, we have already weapon there visible. Let's save and check. It's working. Let's rotate it. And we have all our icons already in each slot. I will clean background so it won't look like that. Okay, so this is working. Let's maybe call it. Now let's use lerp. So we will use alpha of the icon as a mask. Then we will use UDIM color. So this is our background color, and we connecting it to the A, and then our texture into B. So now if I will connect it to base color, save, here we go, clean, perfect. Now let's combine with our this pattern because we lost it. Now what you saw is only normal information. You see there is no black, only this normal information, and we don't need this color anymore. First of all, I want to control a little bit where is metallic and where is rough and not rough, and this yellow piece I want it to be less glossy, but then black, it should represent more like a metal. So let's invert it. So let's use red channel, invert it, and connect it to metallic. So now you see this yellow, it's already darker. It represents metal. Let's create lerp, connect this one into alpha, and from this into roughness, like that. So now dark, it's our pattern in the center. So let's make it 0.2, and this one even lower, shiny. Now let's add like black color there, but I don't want it to be like pure black. So let's use lerp. Now from this one as a mask, and then from this one into B, and this will be our this corners, and I want to set it to like 0.2. I could add color, but I will just make it dark gray and into our base color. And as you can see, it looks like that. Looks good. And finally, what I want is just add some emissive to this, because I want this centerpiece look more kind of like a screen. Let's multiply this with that color. By multiplying, it means where black is basically will be removed from our image. So this is what we want. We don't want black areas to glow, just only this yellow. That, then let's multiply it, and in here, in this multiply, we will add intensity. So this will be glow intensity. Maybe set to 10, and into emissive. It looks nice. Let's add light trick, night, devices, environment. Here's environment light trick. There is directional light. Let's set it to 0 and not affect world, atmosphere. So basically, I don't need anything of that. What I want is just post-processing. Visible, highlight as well, no. Don't affect. Height, no. See this basically, lumen exposure and basic exposure. This is what's important. So now I'm on a high, and On the high fully, it's basically using lumen. So this is what I want in here. And just in case, I will set priority really high, because under the hood there is another post-processing volume. So by this, I'm just like saying this one has higher priority. So exposure 0 or even minus 0.5 and 0, fine. Then we have bloom, set it to 0.5, glows, better. Okay, well, we can add some vignette, so it's basically darkening edges. In a color grading, in a global, I will increase contrast a little bit. Okay, fine. We have that. We need to lower our intensity. Looks fine. Okay. And final touch, what I want to do is basically add lines. Maybe you saw my vending machine tutorial where I basically added some lines moving on the screen. So this is basically what I will do as well. Okay, vertically. So this is how many lines we will have. And this is sine. You can see already many lines and they're moving down. I want it to be really subtle. Okay. And oh yeah, before that I will add that one line as well, like stronger one and moving faster. I want this, that. I don't need multiply, I want subtract time. It's actually that one. And sine, line speed. Okay. And what last thing I want to do is basically remove the lines further away from the screen. Otherwise it will be super noisy visually and will look really terrible. So I want distance blend, and this will go into alpha, and in here instead of 1 I will set it to 0.2, and distance will be, you can try your own distance. I will set it to minus 200. It's quite far away. And then this one is blend range, is make sure that it's not changes really rapidly, but it basically will smoothly transition. Okay, so this should work. So now in here where is emissive, so I will just multiply it with that. So before intensity, and this is how it looks. Okay, that looks good. Let's save and close. Let's open our material instance. Oh, what I forgot, let's add glint actually. It's again very easy to do. So this is the place to add it. Just like that, and it's done. We added glint. I'm not categorizing parameters. Already done it in previous videos. So I really recommend to do it just for organizational purposes. But yeah, it's up to you. Now let's open material instance. So you see like all these parameters could be organized much better. First of all, let's see. Look where it starts. It's actually too fast. Okay, so you see it starts here on this blade and then moves on the weapon. Why? Because actually our range is -1 to 1 and it's in UV space. Why it was -1? Because it's supposed to be starting off the UV space and then go through UV space and end on the left side of UV space, like out, right? But we have now 16 spaces and that's what we need to account to. So we need to start in -1 still, but instead of maximum, I will set it to 16. And now we need lower speed by increasing this number. And now you see, like, we can't make it to work on all of them same time, but basically what it does, it goes from the last one. See, glows are our last number. So it starts with the glows and it goes back and then it finishes on this rifle. So it goes opposite direction. Okay, so maybe set it to 0.1. This thickness, it's really too thick. And the rest I think it's fine. Okay, now on the screen, I think everything is fine. Yeah. Okay, so now I want to show you these few things, the last ones. So we have our rotation. Okay, so we're rotating, and let's say I'm stopping on this weapon, right, on this slot. So now in the code later, I'm just saying it's basically free because it's again 0. It means there is no winning. That's why, like, we want the 0 because we want to disable it. And now we're starting, instead of as in array from the 0, we're starting with a 1. So it means free, right? And that's it. So we have our animation, rotation, and background color change. And same, we can set it that. And next one, for example, if I will set rotation 0 and now first icon, so our first icon is this one, second icon. Okay, so all that is working, and again we have only one material, which is pretty cool, instead of 16. So it will be much easier to control inverse this, and we can rotate inside of the material, so there is no glitches as previously we had. Sometimes our wheel, it's kind of like a jitters or something, or like warms up when we are spinning it, but here there will be no glitches at all, and this is working, and it looks nice. Plus we can put it as we like and it still will spin in any direction, so it's in local space. And we can update our icons on the fly, so it's not an atlas. So we can do this in UEFN pretty quickly. So many advantages. And in the next video, I will show how to use just only one item grunter instead of 16 to grunt all these weapons. So it will be one item grunter, and it will be everything done from the verse into the material directly. So stay tuned and see you later. I would like to say thank you to my all supporters. I appreciate your support. Thank you for your generosity. You can join our growing Discord community, where we like to discuss UEFN tips and tricks, showcase our work, and help each other. You can find link in the description or in the channel header. You can get project files on my Patreon or just buy me a coffee to support me. If you're interested in learning more about UEFN materials, coding, widget UI, and more, feel free to subscribe and click that bell icon to get notifications when new videos will be released. See you soon.